It may not look like it, but I'm creating one of the strongest and most versatile materials on Earth: graphene. You've probably heard buzz about it. Graphene made big waves back in 2004, and it's knocked around science news ever since.
A global race for graphene.
You know, it's not just limited to one little thing.
One
it
of the
seems to be
greatest
extraordinary.
discoveries of the 21st century.
Graphene could be the key to a lot of mind-blowing technology.
But that was almost 15 years ago. Where are all of the graphene wonders that we were promised? The bulletproof armor, the graphene circuitry, the ultralight airplanes, the graphene medicine, a space elevator.
So the next time man walks on the moon, maybe he'll take the elevator to get there.
Clearly, lots of the buzz never went anywhere. But graphene does exist. Engineers have gone from making one fleck at a time to producing it by the barrelful.
Do you want to try to pick it up?
Sure. So the graphene revolution we were promised may already be in motion.
Graphene holds the promise of the future of engineering and technology. It's like a miracle substance. It was discovered in 2004, and we've had a lot of trouble making it until now. Graphene is a one-atom thick lattice of carbon atoms. It's supercapacitive, electrically conductive, biodegradable, 200 times stronger than steel, can take pretty much any shape, and is ultralight. It's been theorized to help clean up nuclear waste, easily filter salt from seawater, could make ridiculous headphones, is biocompatible, meaning you can hook it right up to biological cells, read cyborgs, what else? Right. Help make space elevators a reality, create flexible computers, unbreakable phone screens, and create the base for new supercomputers. Needless to say, the shiz is tight. The problem is, it's kind of really super hard to make in large quantities. It's what supply chain management people would call an issue with scale. Though, admittedly, they say that they could, maybe, scale this up. This stuff is so incredible that everyone is working to try and figure out how to make it. But it's just too expensive to make at large scales outside of the laboratory. Though a new 2017 study in Nature Communications detailed how to make graphene in a single step by heating soybean oil to 800 degrees Celsius on a nickel foil, it would cause the carbon to arrange into a single one-atom thick sheet of graphene. Slightly hotter temperatures made the sheets of graphene a little thicker. This method is fast, it works in the open air, most others require a vacuum chamber, and could cut the cost of making graphene tenfold. Though again, they're still not scaling it very well. The largest sheet created thus far was about the size of a credit card. Funnily enough, a physics professor just patented an accidentally discovered high-yield graphene creation system. It's scalable, it's affordable, and like the soybean method, it doesn't use nasty chemicals, which a lot of older methods used. To create this, they literally explode acetylene and oxygen using a spark plug. Acetylene provides the carbon for the graphene to create itself in the heat of that explosion, but they don't come out in nice sheets that you can use to make stuff, rather in chunks. I mean grams of chunks, but chunks. The yield of other methods is measured in milligrams, so this makes way more, but the problem, because nothing is easy, is the graphene isn't as high quality. So they have to fix that, maybe by getting it out of the explosion chamber sooner, they think? We'll see. At least one group of researchers are looking beyond that to when all these problems with making graphene are worked out and are molding the ultralight material into a fluffy, cobwebby network. Their design, published in Science Advances, details how MIT researchers addressed a problem with graphene. When turning it into shapes, big ones, you lose some of its incredible properties. By looking at the atomic structure, they found part of the magic of graphene is the way the atoms are interconnected, the way they look. By mimicking that atomic design on a macro level, they created this weird shape. That mimicked shape lets graphene keep its amazing properties. We just have to figure out how to use that to construct buildings. It's lighter than a plastic bag, but stronger than steel. Someday, they could grow graphene in or on molds just like this one and use them to build a bridge.
Basically, it's hard to create a one-atom thick sheet of anything, and it's also really hard to get a completely pure sample of anything, and here, we're trying to do both. But then again, the silicon industry faced the same purity problem 50 years ago, and we eventually solved that problem with time and some money. So with some more time, and some more money, I'm sure we'll do the same thing for graphene.